In this lecture, part 2 of talking about MANOVA, we're going to learn about KGroup MANOVA, meaning more than two groups. And we're also going to talk about how to conduct those follow-up analyses and post-hoc analyses that we discussed in part 1. Make sure that you download the new dataset. We're going to be using a dataset that includes only US data. You can find it in the data files on Canvas. All right, so let's talk about KGroup MANOVA a little bit. So first of all, just a reminder of some of the assumptions. Make sure that you check these and go through the steps of ensuring that you feel like this data is going to provide correct assumptions in order to conduct a MANOVA, or being able to indicate in which cases it might be violating these assumptions and cause some problems. And remember, these are the options. Today we're going to talk about option number 1. If we see that the MANOVA is significant, then we're going to do these follow-up univariate ANOVAs for each dependent variable, and then conduct, if those ANOVAs show us that there's something to look at, then we're going to conduct follow-up pairwise comparisons using the post-hoc procedures in SPSS. So for KGroup MANOVA, this time we might ask the following research question, which is using the new data set that includes only US data from PISA. When students have more opportunities during math class to express their own opinions, do students differ in their academic achievement related to both change in relationships, which is PV1 MACC, which is similar to algebra, as well as space and shape, which is the subtest called PV1 MACS, which is similar to geometry. So in this case, we've got two dependent variables. One of them is the change in relationships. The other one is the space and shape. And then the independent variable is this opinion variable, which students were asked how often they were, or they felt like they were able to express their own opinions in their math classroom. And it was rated on a 4-point scale. So 1 meaning every lesson, 2 meaning most, 3 meaning some, and 4 meaning never or almost never. So first we're going to run the MANOVA, then we're going to look at those follow-up ANOVAs, and then we're going to conduct the post-hoc pairwise comparisons. All right, so let's go to SPSS. And just to get an idea of what this looks like, let's go ahead and do some descriptive stats on the opinion variable so we can get an idea of how imbalanced it might be. You can see here that definitely as you get towards never, there's not very many people in there, but otherwise it seems to be pretty fairly balanced. If you look at the percentages, about 1/5 of the population is in each of those categories, with much less in category number 4. All right, so then if we go to the multivariate model, let's go ahead and run that and see what this looks like. So go to general linear model, multivariate. And then this time the dependent variables are going to be the PV1 MACC and PV1 MACS. These are MACC is change in relationships, and MACS is the space and shape variable. The fixed factor is going to be the opinion variable. So remember, this is coded as 1, 2, 3, 4. So if you remember from the last video, when we were using the country variable, things were coded as letters. And so we had to use the automatic recode to translate those into numbers. This time we don't have to do that because the opinion variable is already coded as numbers. All right, now let's look at the options here under plots. Let's go ahead and create this plot with opinion on the horizontal axis. Continue. Estimated means, let's go ahead and do one for overall. Under options, let's go ahead and look at descriptive statistics, effect size. This is how we're going to get partial eta squared. If you remember from part 1 of the video, we talked about how that is similar to an r squared value. Observe power and homogeneity tests. Continue. And then let's go ahead and have it run posthoc tests just in case we need them. We don't know if we're going to be able to assume equal variances. For now, let's assume that that's going to be the case, because if you think about PV1 math scores, even for those two subtests, it's likely that they are probably very similar, but we may have to come back and grab this other one. All right, and let's do the Tukey HSD here. Click OK. All right, and we see that we have the full sample here, meaning everyone had a value for both of those scores, which we could have anticipated. Those scores, remember, are statistically generated. If we look at the means, it does appear that there is some separation between the highest and the lowest amount of opinion being able to be expressed for both. Fairly slight changes, though, from always having an opportunity or at every lesson compared with most lessons. There's not much of a change, and that's probably expected. The same thing with space and shape. All right, if we look at the multivariate test, last time we used Hotelling's trace because it is very similar to a t-test value. And this time, because we have more than two groups, we're going to be using Wilks lambda. You can see here, that's the intercept. For the opinion variable, Wilks lambda has a p-value of 0.02, so it's telling us that it is statistically significant. So in response to our question, we could say that it appears to matter how much opinion students have, or how much opportunity students have to express opinions during math class on their mathematics achievement. We don't know if that is different for these two subtests. And we also don't know if there are only specific levels of opinion, or maybe it depends on the amount or the frequency of being able to express their opinion. Partial eta squared is very small, as we saw in the last part 1 video too, was very small, 0.002. So about 0.2% of the variability in these two subtests can be explained by the amount of frequency with which students could express opinions. Doesn't look very great. Levine's test of equality of error variances, not statistically significant. That's a good thing. We want to see that. It tells us that we can feel confident that we've met the assumption of homogeneity of variances for the ANOVA. Here's the ANOVA results, test of between subject effects. And on the row that says opinion, you can see both of our dependent variables here. So this one, which is basically like an algebra subtest, MACC, p-value of 0.002. The geometry subtest, p-value of 0.003. Once again, partial eta squared is very small, which you'll notice down here is the exact same thing as r squared. So it looks like it is true for both of these, and what we still don't know is where those differences exist. So are those differences the same between each of those levels of frequency? So students who have every lesson versus most lessons, are those two groups of students different in their achievement? scores? Or is it just between students who had it every lesson and never? So that's what the posthoc tests are going to tell us. So if we scroll down here, let me move this over. So this first one here is for the algebra, MACC, change and relationships. And you can see this is group 1. 1 means every lesson, 2 means most lessons, 3 means some lessons, and 4 means never or hardly, almost never. And then this is just the difference between them. So 1 minus 2, 1 minus 3, 1 minus 4. And we would hope that students who have every lesson the ability to express their opinion would score higher than all of these other groups. And we do see some of that here. However, look at the small difference here between every lesson and most, 2.9. So the significance, the p-value is not statistically significant. That's very large. But whenever you look at 3 and 4, there is a difference. So students who said they had some or never scored statistically significantly worse than the group of students who said that they were able to express their opinion in every single lesson. However, even though these p-values are small, 0.021, 0.013, look how big the confidence intervals are. So that difference, even though here it says 12 points, 17 points difference, the confidence interval indicates that in the population it could be anywhere from 1.3 points to 23 points. And between those who had it every lesson versus never could be anywhere from 2.6 points to 32 points. So that's a very big range. It could be negligible. It could be more substantial. A difference of 32 points, that's similar to what we see with this data set in the impact of SES on students' overall math score. And if we look down this row for results that are statistically significant, this one is close. If we use a cut score of a cut alpha of 0.1, that would be statistically significant. If we stick with 0.05, it's not. So this group 2 seems to not score statistically significant than anyone else. And 3 only scores differently than group 1 here. And 4 scores differently only than 1. So what we're seeing is that really it's those who had the ability to express their opinion every single lesson scored much higher, or at least statistically significantly higher, than those who had it some lessons or never. With change in, with space and shape, the geometry subtest, we see the same thing. The differences are between group 1 and 3 and 1 and 4. That's where we see the p-values that are small. Once again, the range of the differences in those scores is quite large, 1 to 23, 2 to 32. We don't see any other statistically significant differences. The only differences are between 1 and 3 and 1 and 4. All right, let's go back to our slides. So if we were going to write this up, we might say something like this. The MANOVA indicated statistically significant differences based on frequency of opportunity to express opinions during math class. Wilks lambda 0.995, p-value of 0.02, and partial eta squared of 0.002. Follow-up univariate ANOVAs using a Bonferroni corrected alpha of 0.05 divided by 2. Now remember, with the ANOVAs, we don't have a way to tell it to correct those alphas, whereas with the pairwise comparisons, there's a checkbox for Tukey's. So we have to do that manually, but it's pretty simple because there are 2 dependent variables. There's 2 different ANOVAs, so we're simply dividing our normal alpha of 0.05 by 2 and using 0.025 as a cutoff value. And if we go back to SPSS and look back up here, I mean, the p-values were 0.002 and 0.003. Those are still less than the 0.025 that would be used with the Bonferroni. And that revealed significant differences for both the algebra subtest, F is for 4.84, p-value of 0.002, and for the geometry subtest, and there's the F and P values. Posthoc t-tests for pairwise comparisons utilizing Tukey's HSD further indicated statistically significant differences as follows. And I've put this in a wording format here rather than just giving the values. So the way we would interpret this, remember, students who had opportunities to express opinions in every lesson were different than those who had some or who had no experience or opportunity. So students expressing opinion every lesson scored between 1.3 and 23.3 points higher. Now this comes from the 95% confidence interval. On average, and that's important, remember, this is not precise. This is on average. Everybody didn't have this difference. It's on average. Then those who only expressed opinion on some lessons, and then we report the p-value. Students expressing opinion on every lesson scored between 2.7 and 32 points higher on average than those who never expressed opinion, and a p-value of 0.013. And then we do the same thing for space and shape. So for space and shape subtest, students expressing opinion every lesson scored between 1 and 23 points higher on average than those who expressed opinion only on some lessons, p-value 0.026. And then students expressing opinion on every lesson scored between 2.4 and 32.2 points higher on average than those who never expressed their opinion, a p-value of 0.015. And then of course, if this was in some kind of actual paper, then you would go in and unpack that a little bit using theory to help understand and make sense of why this might be the case. All right, so that is it for part 2, dealing with KGroup MANOVA.